All right. So before showing the time graph, I just want to go over a couple things, right? Right. I want you to understand the difference between distance and displacement, right? And I want you to understand the difference between speed and velocity, right? And then we'll learn about acceleration after, right? Right. Before I do this, physics people, like pick on Nuria. What's the difference between these two? What's the difference? Begin with S. One is S and one is B. S and B. One is a scalar and one is a vector. So there's a scalar quantity, vector quantity. What does that mean? It means direction, important, purity. All right. So what you say, let's say I gave you a little triangle, O, A, B. And I said, let's say here is 4 meters, here is 3, they're not looking realistic. Here's 3, here's 4, and here's 5. Right? So what's the difference between distance and displacement? Right? So if I said, okay, an object traveled at O, he went to A, and then he stopped at B. What's the total distance traveled? O to A, A to B. That's 3 plus 5 is 8. That's okay? So distance is the total length traveled. The first time you're hearing that, write it down, right? Distance is the total length traveled. What about displacement? The displacement is if I start here but I finish here, displacement is a straight line distance from where you start to where you finish. So your displacement is how much? What's the displacement here? Straight line distance from where you start to where you finish. The displacement is 4. That's okay? So write this down. Distance, total length travel. Distance is the total length travel. Total length travel. Distance, total length travel. Displacement. Displacement is a straight line distance. Displacement is a straight line distance from start to finish. Straight line distance from where you start to where you finish. Right? From where you start to where you finish. So as a quick example, just draw this now, please. The displacement was 4 meters and the distance was 8 meters. Draw this, please. Draw this back, right? So when you see the word distance and displacement, they are not the same, right? One, you have to consider direction, the next two. Right, and some that even done, right? Draw a diagram and the distance from O to A to B is 8, and the displacement from O to A to B is 4. So I draw this diagram, right? And then write it back. So that's the difference between distance and displacement. Now, what is speed? Speed is basically the ratio of distance. The ratio of distance on time. That is your speed. Velocity is your ratio of displacement on time. Right? So what that does, it makes velocity a vector quantity. It makes velocity a vector quantity. Right? Real easy, right? Don't let the word vector confuse you. All it means is this. If you go in this way, your velocity will be positive. If you change direction, your velocity will be negative. Right? In maths, you don't need it so much, but there are one or two questions where I saw you have to understand this, right? So velocity is your ratio of displacement and time, speed, ratio of distance and time. Copy it down. Last one. Right, please. Add this in here. Add this in here. Velocity in one direction positive, change direction is negative, right? Add that in, right? So you understand what vector means for velocity. Right, and lastly, what is acceleration? Acceleration is change in velocity. Acceleration is change in velocity over time. Right? That is your acceleration. Right? Acceleration is change in velocity divided by time. So once I use these terms, you'll have an idea of what to do, right? Right? Change in velocity on time, or I didn't give you the SI units. This SI unit is meters per second. This one is meters per second. And this is meters per second squared. Right? These are called the SI units, right? Well, what you'll write your answers in. Meters per second, meter per second squared. If an object slowing down, what is called that? Deceleration, right? So if an object slowing down, it's called deceleration, right? Can you look at that, please? Right? Deceleration is when an object is slowing down, right? Right? So there are two types of graphs that we're going to get. we will get distance time graph or displacement time graph, right? Right, so I want to explain each one of these graphs. Look up here. Ready? So watch here. So a displacement time graph, right? It tells you, Elijah, a displacement time graph gives you an idea how displacement changes with time. Okay? So let's say we have somebody, right? Let's say we have Frankie here, right? And Frankie wants to walk to the cafe. Right? So cafe, let me say you do that there, you do that, you do that. Right. So let's say the distance from here to here is about 5 meters. Right? Let me pretend it's about what? 2, 4, 6, right? Right. So here's what happens. Frankie starts here, right? And then Frankie moves to the cafe and let's say that's seconds. So the cafe not too far, right? Let's say Frankie took 5 seconds. Frankie took 5 seconds to walk this 5 meters here. How are we going to show it in a graph of Frankie here now, right? How are we going to show it on the graph? He took 5 seconds to walk about 5 meters. So his first part of the graph was still like that. That's okay? Right? So he walked from 0 meters to 5 meters in 5 seconds. That's enough? Let's say now that he stayed at the cafe for 10 seconds. Would his distance or displacement change? No. So he will stay like this. Right? He will stay there for 10 seconds, right? 5 plus 10 is 15. That's okay? Let's say now Frankie decide now, so he went this way. Frankie decide now to go back to where he started in the next 5 seconds. When Frankie reaches back here, what will be his displacement? So Frankie went here, he went to the cafe, and he come back here. What will be Frankie's displacement here? Read over the definition. I want to ask somebody who's not doing physics, right? You're doing physics? No, no physics. Right, Tishon. So you start here and you finish at the same place. What is his displacement? So you start and you finish at the same place. What's the displacement? We read the definition again. For displacement. Straight line distance from where you start to where you finish. So if you're at the same place, what does that mean? Huh? No. I want to tell me what value will the displacement be. So if you start here and you do all of this, but you come back right here. What's the distance? And when you start and finish at the same place, right? By a distance, what is the displacement? 0. Right? 0. So it will be 0. So in the last 5 seconds, you're coming back at 0. So you come back here. Are you okay with that? So this graph shows Frankie's journey from the classroom to the cafe and back. That's okay? You okay with that? Question. Let me pick on Elijah. Elijah, during which part of this graph? 1, 2, and 3. Was Frankie moving? Which part of the graph? 1, 2, and 3. Where was Frankie moving? What? 2, he was moving here. 1 and 3. right? So during phase one and during phase three, Frankie was moving. Yeah. Yeah, that's not right. So Frankie moved during one and three. So you know what that means? If he moving, he has a what? He has a velocity. So it means that there must be a way for us to find velocity here. And that brings us to the first thing, the slope or the gradient. The slope or the gradient of a displacement time graph is velocity. That's okay? Yeah? Does it? So if you find the gradient here, you would have find Frankie's velocity. If you find the gradient here, you would have found his velocity. That's okay? So one very important thing I want you to learn from a displacement time graph is that the slope gives you velocity. That's okay? Copy that down. So whenever you see a displacement time graph, or sometimes you will see a distance time graph. Right, so there's two types of graph we have to learn, right? Distance time graphs and velocity. We are going to put down distance and velocity. Speed time. Right, so after you draw the displacement time graph, draw the velocity time graph. And just write those two small things. All right, so once we see these graphs, we have to understand these little things here, right? I want to just re-explain what you're seeing on that graph, right? Right, so remember on this graph, it's showing that he moved in one direction. He stayed for a little while at rest, and then he went back to his starting point. Okay? This graph a little bit different because it's a velocity or speed time graph, right? If you see speed, same rules apply. Okay? So here's what this graph saying, right? Just look here for a minute, right? Look up here for a minute. So this graph saying that a person started at rest and moved and increased his velocity to some value, right? So during this phase here, he has a gradient, so he has an acceleration. So the person accelerated here, but you'll recognize that this is a horizontal line. It doesn't mean stationary. It just means moving with a constant velocity, right? So this is constant velocity. It has no gradient, so it has no acceleration, right? So acceleration, no acceleration, and then you would recognize that the velocity here is something and here is zero. So it slowed down, right? So you call this what? This is acceleration. This is what? Deceleration. So the person accelerates, moves with constant velocity, and then decelerate back to rest. Okay? All right, let's catch those things. And then we will see if we can apply this, right? The time, draw those graphs, draw the graph, and then you're down, and we're gonna try a few, right? First thing you have to do is look and see what type of graph it is, right? Are ready? Let's go. Right, for those who have it, it's a topic by topic in a group, right? It's not same, so that. First one, June 2017. So the velocity time graph shows the motion of a cyclist over a period of 40 seconds, right? What you see? Y'all see that? But it's saying that part one, calculate the gradient part A. But before I calculate it, let's click on Capricorn area. Now we talk about Jaden. What does the gradient O to A give you? Look at the type of graph and then look at and then tell me what the answer is. What is the gradient of what type of graph it is? A velocity time graph. You see velocity on the y, time on the x, right? What is the gradient of that graph give you? Watch, I can see it in the later on right now. Huh? Into the time. What is the gradient? What is the gradient of slope give you? What is the gradient of that slope? If you find that slope, you get the area. Look, it's still right here on the board. Gradient is what? Acceleration, right? So if you all find the gradient there, you'll get the what? Acceleration. Right? So part 1 and 2 is to find the gradient of O to A and gradient A to B. Hurry up. Find the gradient. Without working it out. Without working it out, Alex. What's the gradient of AB? Without working it out. What's the gradient of AB? Huh? Are you guys 10? Boy, 6. Does that line have a slope? Look at the line AB. Does it have a slope? Is it slope? No. So the gradient is 0. Right? The gradient AB is 0. Right? The gradient AB is 0. Right. All right, do the next part, find the gradient. Right here, final gradient. Final gradient. Yeah, but oh, there's some more left, right? No, I wasn't some working. Yeah. Huh? Right? Good. Right, for those who don't remember how to find gradient, just read off 2 points. Read off here, that's 0, 0. And read off here, that is 25, 10. So the formula for gradient is what? Y2 minus Y1 over. Right, remember it's maths, so you had to show them all of that. Right, so 10 minus 0 over 25 minus 0. Right, so I got 2 fifths or 0.4. Right? 0.4. Everybody okay with that? Copy it down quickly if you don't remember how to do it. Write down the formula, y2 minus y1, and then write down the value you got, right? First one in the topic, like it's Jan 27. Right? Next. You'll have it right. So the gradient is 0.4 from O to A, and A to B, the gradient is 0. Right. Right. So here's the exciting part. What we have to do now is in words, we have to fill everything out here. How are we doing that? Yeah, we can't see the graph. And that's right here. For all the blind people, take a picture there now. Take a little pic and let's work out that. Take a little pic of the graph, right? That's the most important thing. Take a pic of the graph, and then we're gonna go through the pattern. This is the thing. Is it going good? Open up topic by topic and get question. All right, ready? So what's the graph? Everybody have the graph? Everybody have the graph? All right, let's go. Let's pick on who to pick on, who to pick on, who to pick on. And head start to go down. Correct. Sit your head up. Correct. Correct. Tell them out here, boy. Correct, boy. The cyclist from rest. Huh? Right. The cyclist from rest. Where his velocity is what? The cyclist from rest, where his velocity is 0. He has rest, right? Steadily increase his velocity by something each second for the first 25 seconds. Not real hard, eh? Not real hard. Be careful. Hear what it said. So the first part is 0. Right? Watch it here. Here's what it said. Right? It steadily increases velocity by each second during the first 25. Think about it. It is not 10. First velocity. Right, yeah. So what's your came up with? Second one is 0.4, right? Right, so the second one is 0.4. Right, so technically what they asked there for was the deceleration or the acceleration. Right? Because it said per second after. During the next 15 seconds, the velocity remains constant. That is, his acceleration was 0. Determine the average speed. So I'll give you the formula for average speed. Average speed is after the put together out now there. Remember, what's average speed? What's average speed? Total distance. Total distance over total. Nine. That's the distance. Total. Right. Come back here. Find that place. Find the average speed. Question. What's the total time for the journey? 40 seconds, right? Right. We have a little problem. What's the total distance? Very good. Somebody say that. Somebody, you have to find the area under the graph, right? You have to find the area here. You have to find this area here. Right? You have to find the area here underneath here. You have two options, trapezium, or you can find the triangle here and then find this rectangle here. They want the total distance. Right? What you see earlier? Under velocity time graph, area under the graph is distance traveled. Okay? So you have to learn to find the area. Right? What we have there, the trapezium. You have two options. You can use the trapezium formula, which is what? Half the sum of the Have the sum and parallel side by the height. Or you could break it up into a triangle and a rectangle. Anyone you want. Right? Find the area. Find the area, that is distance, and then divide it by time. Just go. Hurry up. Find the area quick. Right, trapezium is half the sum of the parallel sides by the height. Parallel sides are 40 and 50. And the height is 10. Or you can use a triangle, half base by height, and the rectangle line by height. All right. L time is 40, right? Find the area quickly. And then pass it on to what's the area. Yes. The shape line, right? Right, remember A of a trapezium, half the sum of the parallel sides. Right, so it's half the sum of the parallel sides. The parallel sides is here, which is 40, and here, which is 15. So that's 40 plus 15, and the height is here. Right, the height is there, which is 10. Right, and then it will go down. How much is that? I'll say it, wait on the front. Oh, yeah, uniform of the blue. After somebody parallel side, but that trapezium. That shape the trapezium. Huh? If you get the same thing. See if you get the same thing. You get up 55 on it. What is that? What is 55 divided by 6 point? Alright. No, I just simplified. Oh, they got 6.88? Yeah? That's the same thing. Well, I'm doing it wrong, do it this way. The area of the rectangle is 15 by 10. The area of the triangle is half of 25 by 10. So this is 150, and this is what, 125? That's 275 divided by 40. The formula is average speed is distance on time. You found distance alone there. All right, let's go again. Again, so that example there was a velocity time graph. Gradient is acceleration, area under the graph is distance traveled. Let's go again. All right, this example here is a distance time graph. For those who can't see, take a picture. Send on the group. Right, remember those on the group, just look for topic by topic and go to page 112. I don't have it. Right, zooming into the graph, right? Zooming in here to the graph. Right, well, what type of graph is this? Distance time graph. So that's the first one, right? Right, so the distance time graph shows the 3-stage journey of car traveling from town A and back to town A to C and then back to E. Right. So I'm going to ask a few questions, right? Let's start with all right, let's go. No, okay. Down in the back, Israel. Israel, how long? Look at it. You'll see the time axis. You take a picture. The time axis. Right. The time axis is in what? Time of day. So the actual time, right? Yeah. So Israel, how long did it take in stage 1? It broken up into 3 stages. How long did stage 1 take? How long? Yeah. How long? It is a time. Hour, right? 1 hour, right? How long did they between stage 1 and 2? Giovanni, between stage 1 and 2, what happened? That's here. What happened there? Describe what happened between stage 1 and 2. Sure, what type of graph is this? Is that distance time graph, right? So that represents what? Stationary. Good. Right? Look at stage 2 there. Stage 2. Oh, by the way, how long did the stationary part take? 30 minutes, right? Every block is how much minutes? 15 minutes. Nice. Stage C on top there. So look at stage 3. Right? Joseph, you can describe stage 3 for me. Okay, really hard one, right? That's just in your own words. So number 1, what type of gradient is that? Positive or negative? You sure? Stage 3. Stage 3 is negative. So therefore, we have a negative velocity. What does that mean? Going back. Very good. Right? So stage 1 and 2, positive velocity. Stage 3, negative velocity. And we said that if the velocity negative, it means what? Going back in the opposite direction. All right. So again, who can see? Take a little bit. Right. Answer part 1 to 4 now, please. Answer part 1 to 4. You can take a picture for me, or you can go to the subscribe something. Because if you keep deleting it, probably.
Wait.
And it shows. Oh yeah. Answer part 1 to 4, please. Answer part 1 to 4. June 2016. Answer part 1 to 4. I answer everything, part 1, 2, 3, 4. I just come back down there a little bit. Right? Let's just go back there. Take your time. Remember, we only using the rules for displacement time or distance time, right? Right, remark. First one. State the time of day at which the car arrived at town C. What time is that? 8:30. Nice.
I did that.
Calculate the total time in minutes, right? Minutes, for which the car stopped during the journey. So during the journey, he stopped here and he stopped here. Here's 30 minutes and here's 15. So the answer is 45 minutes. Determine the constant speed for stage 2. How do you find speed? From the graph. Gradient, right? Gradient, not distance over time, right? Gradient. Right? So remember I told you it's the same thing as before, right? If it's a displacement time graph, it's velocity. If it's a distance time graph, it's speed. Right? So you have to find the gradient in part 3. And then in part 4, total distance over total time. Yeah. Everything, even during the rest.
That was right. I was right.
Oh, no. Calculate the average speed for which it was moving. So no right. Right? It said it was moving. Right? Average speed during which it was moving. So you're ignoring the time when it was moving.
But any total
When it was moving. That's important. When it was moving. Right. Total distance it was total time when it was moving. Right. So you're ignoring the total 45 minutes time then. What y'all got the gradient? How much? What y'all got the gradient? Yeah. Part 3, to find the constant speed. Right. Here's something you could also do that makes gradient easier, right? Watch this here. We want to get the slope here. We would like to get the slope here, right? So what you can also do is find rise over run. Rise is this here. Rise is this total length here. How much is that? 100 to 40. That's 60, right? And then how long is this here? How long is that? 1, 2, 3, 4. That's 1 hour. So it's 60 divided by an hour, which is 60 kilometers per hour. That's okay? That's rise over run. Some of you all use 10, 30 and minus the values. You can't do that, right? This is time of day. Right? So you can't use 730 minus whatever, right? Because you might end up putting a calculator 730 minus something. Don't do that, right? So I want you to also learn to use rise over run. Right? To make a note of that, please, gradient is equal to rise over run. Right? If you were to use 730 and then 830, if you all write 830 minus 730, right? And you put it in the calculator wouldn't give you an hour here. Right? So otherwise do it that way. I prefer if you use rise and run. Okay? So the rise is 60 meters and the run is 1 hour. All right, so the answer is 60 kilometers per hour. You okay with that? The last part is calculate the average speed. What's the formula for average speed again? Total distance over total time. Go ahead. And please, all the question said when it was moving, right? When it was moving. So ignore the time when it's stationary. Oh yeah. Look how that fast, we have one more to do. We can screen. Anyway, next week we'll do the 2025. We'll do the one from this year. All right, ready? Find the total distance, total time. So you're finding total distance traveled here, time, total distance traveled here, total distance traveled here. Right? And at this time now, remember you can leave it in hours, right? Leave the answer in hours. Total distance traveled and total time. Right? While you're working physics, people, what would be the average velocity? Physics people. What would be the average velocity for this journey? You can do it mentally, physics people. What's the average velocity here? Total displacement over total time, right? So what is total displacement? 0. Displacement. Because remember you went back to the starting point. Right? So if they had asked the average velocity, it would have been 0. Okay, we have time more to do because I want to make sure the non-physics people understand what's going on, right? Right? What's the total distance traveled? Up 100, back 100. So the total distance traveled is 200. Right? So the total distance traveled is 200 meters. How long is it? Here looks like 1 hour. Here to here was how much? 1, 2, 3, 1 hour again. And from here to here was how much? 1, 2, 3, 4, 150 minutes. Yeah. So you're going to write 1.25. Don't write that or 115 minutes. Write that or 1 1/4. Okay? Because we dividing meters by I'm sorry. We're dividing kilometers by hour. So that'll be 200 divided by 3.25. And that'll be total distance. Right? It went up 100 and went back down 100. So 200 divided by 3.25 is how much? 61. How much? 61.5. 61.5 kilometers per hour. Right? That was the average speed. Everybody okay how I got 3.25? Right? Stage 1 is an hour, stage 2 is an hour, and stage 2 is 5, stage 3 is 5 blocks, which is 1 hour, 1 1/4. That's okay? Yeah. One more block. One more by great points. Right, I like this one. This one is a talk plan here. Yes, ma'am, I am going to clear it today. All right, June 2010. It shows an athlete during a race. Last one, and we done. Last one, and we are done. Right, I'll pick people in the video to help me with ABS online is real giveaway.
This one is online. So now this one.
All right. You all ready? You ready roll? I'm happy roll up. Not going in the
How you so sure again, everybody?
Okay, everybody.
Looking like that.
Alright, let's go. Let us go. Let us go. Right. From the graph, find the maximum speed. Alex, what's the maximum speed there? What's the maximum speed Tishon? Tishon. What's the maximum speed? What's your graph? Huh? No, the graph didn't reach 40. The graph reached what? 12. Maximum speed is 12. The number of seconds when the speed constant. The name again? 30. 30 help out now. The number of seconds is constant. Watch it good. 4. Very good. 4 seconds. Next. The total distance covered. We're not working it out, just tell me what to do. 30. It's a speed time graph. How we getting the total distance traveled? How we do? Just tell me what to do. How to get the total distance traveled on a speed time graph. Remember, speed and velocity, the same thing, right? It's still on the board. Yeah, it's still on the board. That's not the board, it's board here. How you find the distance on a velocity time graph? Look it right here, distance traveled. So you have to find the what? Yeah, you have to get the area. What shape is that? Trapezium, and the formula is half the sum of the by the heights. All right, nice. Right, during which time period was the speed of the athlete increasing? Look behind. What's the name again? Maria, help me out, please. During which time period was the speed increasing? Look at the graph. 0 to 6 seconds. Very good. Next thing is well. The speed when the time period when the speed was decreasing. Speed is decreasing. What is? Speed decreases. Yeah. Well, what's the answer? From when to when? Time period. So from 10 to 13, right? And last one. When the acceleration is 0, that will go to, that question will go to, who has down there? I pronounce the name properly. Let's try it. Wait, how long this lesson? Thomas. I pronounce the first one. Thomas. The acceleration, when the acceleration is 0. No. All they want is the time period from the graph. Time period from the graph when the acceleration is 0. From 6 to 10. Right? From 6 seconds to 10 seconds. Alright. So next week we'll continue this. I'll do the 2025 question and one more, right? And wrap up this time graph. Anybody get a paper by chance? You have it? A cup of coffee? Yeah, you'll stand on the group, right? Yeah. Right, send the group and you'll do that homework. Forget it. All right, go online. Guys, you can finish.